Hello, everyone. So hopefully you saw our performance in the beginning of 1E9. There we interacted with some instruments that we have built in our studio. And those musical interactions are actually a part of all the technologies we were discussing today, like the blockchain and BevVR. And we're really fascinated with putting our prototypes and playing around with these technologies and actually deploying them on stage. So today we're going to talk about why we do those things and what we actually saw in the performance and where we want to take it next. But I think before we do that, we can think about maybe how disruptive innovations transformed how we create music and also experience music. Right. So let's look at a traditional orchestra. We all know that it is performed by individuals with their own unique instruments, and collectively they form a sound together. This has been the way of creating music, and for hundreds of years everyone kind of knew this as the main medium of musical performance and composition. But something amazing happened almost 100 years ago, where a young Russian scientist named Theremin actually founded a way to use electromagnetism to manipulate this new sound aesthetic, which is the electronic sound. This was founded by the Soviet Union to better communicate how electromagnetism worked and communicate this with the public. So this was one of the first, actually the first inventions where an electronic instrument could be played with a musician, a traditional musician, and of course its adaptation with the normal orchestras. This is a Bach symphony, where for the first time an electronic synthesizer was being accepted to the traditional way of music is experienced, an orchestra, a philharmonic orchestra. And this has basically created a whole new wave of electronic innovations. So the electronic current systems that Theremin built actually led the whole past century. From the Theremin, there was founded, synthesizers, and it became more accessible. And as the interest in those sound aesthetics expanded, we saw customer products like Moog synthesizers. Actually, one of the first Moog synthesizers is in the Deutsches Museum right now. We saw that earlier today. And it basically evolved under the same technology Theremin pioneered. Of course, then we moved into another disruptive innovation with computation. With computation, we were able to create algorithms that emulated the signal flows of the electronic currents that were leading all these analog instruments. And now a stream of data became the musical language. The term MIDI stands for musical instrument digital interface. And it is basically a way of playing softwares musically. However, it still hasn't really moved on from analog synthesizers in the way that they are closed systems. Closed systems meaning it is composed and it is used by people with their computers. However, interaction through the web or interaction, collaboration is kind of limited. So I think we're in a really exciting time where we're moving into this concept of net art. Net art is a broad concept for artistic creation. However, we believe that right now it is really possible to create your art, your music, your digital art on the web, share it with people, make it collaborative, and also experience it in the web altogether. Meaning that we don't really need to create things in the offline systems, later, for example, creating our music and then minting it in a platform. Rather than that, we will create the music from all around the world together in these new tools and these new spaces that are being built today, and it will lead how we create art and music. Yeah.
Can I take this?
Yeah.
Yeah. Kerem is right, and I just want to say, as you know, analog worlds are using electron flows for producing sound, and digital world are using numbers for creating sound and producing sound. And now we are talking about the connections and peer-to-peer connection to making art. Now, I just want to take you with my dream train to the magical world, and I want to show you what is that. And imagine that an instrument that a machine learning algorithm can play with you, and an artificial intelligence plays one of the hand of piano and you are playing the other. And imagine that, imagine an instrument that can do what 100 people can play together. What I'm trying to say, as you know, a traditional orchestra, 100 people playing together individual instruments, so they are producing a sound together, collective sounds. So, but I'm trying to say 100 people can play just one instrument. That means this is really new thing, because, you know, or maybe we can say that one human, one artificial intelligence, and one stream of data can play just one instrument together. This is really new concept to making art. And imagine an instrument, infinitive size instrument, that you can play in digital space and simultaneously physical space. What I did that before at the performance today. So, and imagine that a virtual band in the metaverse, and as famous as Daft Punk, but they met never each other before in real life. So I'm very excited to introduce you Tilda, the new generation of musical instrument, and we are calling that meta instrument, and the new type of making music and doing art and making art or performing art. So this is not just instrument. We are calling that instrument because this is traditional name, but this is not instrument. This is kind of new making art form. This is like a framework. This is like a connection thing, and this is like a technology. So I just want to say, yeah. First of all, I want to give you an information about the first edition and first generation of this algorithm. So early testing. I was thinking about making an algorithm and pushing the limits of the synthesizer. So doing that, I decided to use a machine learning algorithm for new kind of way to sound synthesis. So before for doing that, I decided to use a machine learning algorithm. So I trained that with 18 different parameters and many sound combination of Moog presets and Moog sounds. In this way, I generate really random and really interesting sound synthesis techniques. So for controlling that algorithm, I used Leap Motion, which is an optic sensor. And in this way, I created three-dimensional space which will affect the sound synthesis of the Moog or of the instrument. And after that, we built together another thing. Maybe you can explain that. Yeah, take this.
So, by the way, a funny way, the prototype actually plays in a similar way to a Theremin, except there's a sensor, and the XYZ positions are being tracked, and the machine learning, follows the hand movements, creating the sound synthesis. But later, this prototype, we were in discussion with IBM. We actually had the chance to integrate this prototype into their cloud infrastructure. And there we basically created a second version of it that could be played with and connected with any web application. And all the wired connections were basically removed, and it was all IoT based. So when the hand movements are tracked by the sensor, it doesn't directly go to the visual or music system. It first transfers the data into the cloud, into a server in Frankfurt actually, and later all our systems subscribe to this flow of data seamlessly in real time. This is very exciting because we're on the edge of 5G and even faster connection speeds being in that infrastructure. So now I think it will be even more possible to merge virtual and physical musical performances in real time. And this ties to what Mehmet showcased in the performance, our third prototype of the Metaverse synthesizer.
Yeah.
Maybe you assume the whole program was in our computer, but it was not. It was a web VR experience, meaning that if Mehmet was in Tokyo, or if he was in London, or if he was in Istanbul, he could still play with us. He just was here, but he didn't really have to be, because this is what the web VR allows us. And as you know, our headsets, AR headsets, VR headsets, need to be smaller. We really believe that internet-based applications will just be more accessible and be more applicable to all the new stuff coming along.
Yeah, you're right. At Performance today, I play them VR instruments, and it's really a completely web-based instrument. And I used WebGL technology, web audio, web communication, and WebRTC, and peer-to-peer connection. In that way, you can play with your band, or you can give a concert, a solo concert to your audience, and you don't have to be there, actually, there. Or you can give a concert in a metaverse to another metaverse. Or you can give a concert in metaverse to physical world, like I did today. Yeah.
All these special combinations and narratives can tie with the artistic experience. And it's up to the artist to make their choice on how this connection will happen. So I would also love to talk about our next plans. Currently, we've been working on machine learning and IoT messaging the past few years, but now we're really excited to explore this crypto scene and how we can integrate musical instruments into it. We're currently about to launch our crypto synths, which will be NFT instruments that you will own. And when you gather into a virtual space with those NFTs, you can integrate them and you can perform with them, just like you own a normal instrument. And meta synths will be meta instruments that you can bring along to other metaverses, like let's say Decentraland or the new ones that are being built. They will all be adaptable to many metaverses in the future. And of course, the libraries that we build them on are being developed every day. And with our team, we hope to actually pave the way for new libraries and new documentations, so that the stuff we build can be open source, and basically anyone can build upon what we try to do in our products.
Yeah.
Finally, we also, Meta's teaser, Facebook's teaser, and we actually wanted to also visualize our ideas on how this musical experience could be in the metaverse with our developments. So we created a short clip, and we can watch this.